Hi, my name is Andreas, and today I will show you how you can configure PikeOS in CODEO. Let's go!
Welcome to A Cup of CODEO, your 5-minute tutorial.
We start in the CODEO main perspective. On the left-hand side, I have a QEMU simulation target prepared. If I run the target, we can see letters printed to the console screen. In fact, we see two PikeOS processes here running in parallel on the target. The code of these programs is quite simple. There is a loop printing the letter B and another program that prints letter A with some indent for better readability. These two programs are running in PikeOS with a so-called priority scheduler. In my configuration, both of the programs have the same priority. Effectively, the PikeOS scheduler takes care to run them both in parallel on the same CPU. However, PikeOS also offers the scheduling of time partitions. Let me show you how to set this up. First, I will create a new schedule scheme with the name schedboot. This name is special and signals PikeOS to run this scheme immediately after the system has booted. Now I will add a time partition window. It needs a duration and a unique ID, which is 1. Now I add a second window. I change the duration to something different and also give it a unique ID. I use the ID to assign the time partition to a certain process. You can see the colors changing. Once this is done, I have to save and rebuild. Now I'm ready to run the target again. We should now see the processes printing one after another in different length according to the window size. And this is exactly what we see here. The time partition window for B is longer, so we see more letters B on the screen. Okay, let's go over and assign the process to different CPU cores. These filled black blocks visualize that all our 4 CPUs are assigned to this schedule table. Because all my processes are single-threaded, they will effectively run only on core 1. To assign CPUs to certain time partition windows, I have to mask them in their window table. So I start with creating a new window table first. Then I create a new time partition window. Again, I have to give it a duration and a unique time partition ID. In my case, I use 2 as this is already assigned to my second process. We can delete the other window. With the CPU mask, I mask out the CPUs that I don't want to use. In my second window table, I want to use CPU 3 and 4, which is the mask OXC. In my first window table, I want to use CPU 1 and 2, resulting in mask OX3. Here we see the result. According to the black boxes and the white boxes, we can see what CPUs are enabled and what are masked out. Save and build again. Now both of the processes are running in parallel in different time partitions on dedicated CPU cores. Depending on your application, you can now add more time partition windows and processes in the same manner.
And that's it. I hope you liked it. See you next time.
You can try out our CODEO IDE together with a free ELinOS test version. Go to our website and start your experience.